Good morning, everyone. Guru Sri Shanti Vijay, Jain College for Women, heartily welcomes the guest speaker of the session, Dr. M. Lavanya, HOD and BOS Chairperson, Department of Computer Application, Sri Vidya Niketan Engineering College, Andhra Pradesh, for the webinar on data analytics and machine learning approaches. A word of prayer in the morning means a day of blessing. To begin this auspicious occasion, we shall begin with the prayer song. Now, may I request Dr. P. Carmichael, ma'am, Head, Department of Computer Science, to deliver this welcome address.
Join with us on behalf of GSS Jain College for Men. It's my immense pleasure to welcome our guest speaker, Dr. Ms. Lavanya Ma'am, for the webinar on data analytics and machine learning approaches. Dr. M. Lavanya started her career as an assistant professor in Sri Vidyaniketan Engineering College, Andhra Pradesh, in the Department of Computer Science and Applications, and now she's an associate professor heading the department. She specialized in Informatica and R analytical tools, which enables a fresh graduate to immediately select by software companies during the campus recruitment. She is a member of various associations like International Associations of Engineers, International Associations of Computer Science and Information Technology, uh, etc. She has been a resource person to various online and offline workshops. She has published many number of papers in national and international conferences and proceedings. I'm very much elated to welcome Dr. M. Lavanya again for the day. Thank you, ma'am, for gracing this occasion and share your knowledge with us. Thank you, ma'am.
Now, let's commence on our session. May I request guest speaker, Dr. M. Lavanya, ma'am, to take over the session.
Good morning to all dignitaries and participants. I thank management of Guru Sri Shanti Vijay Jain College for Women for giving me this opportunity to act as a resource person for this national level virtual webinar on data analytics using machine learning approaches. I especially thank Honorable Secretary Dr. Gautam P. Vadisar, Principal Dr. Malati Ma'am, Head of the Department Karumoli Ma'am, and Sri Lakshmi, program organizer, for inviting me under the Department of Computer Science. In today's world, as all of you know, that data made available increases tremendously, right? Now I'd like to share my PPTs where we can go ahead with how this data, which is growing day by day in petabytes, in gigabytes, how the data analytics can be performed using various machine learning approaches. First, we come to the data analytics introduction. So before going for a data analytic introduction, just we have a brief introduction of what for the data analytics. So when we go for data analytics, which gives them an advantage over their competitors in the successful business industries, to identify in which areas either their services or the products need to be improved, and where the sales might have been increased or decreased, and where there might be many loopholes in the market. Also, the business analyst is making use of this data analytics, which is growing in the current business industry. As all the students are aware of, that the business analytics or the data analytics job, whatever you are gaining is getting the double the package. So once you are a very good programmer, you can go for getting as a fresher to the maximum of 13 lakhs. But once you become a data analyst, it is a chance for the students where 50% to 100% double the current salary, like we can go with 20 lakhs per annum. And many users get using this data analytics. Many users are going to get more information as well as significant potential in creating their business value. And that is why the business analytics has becoming the demand in the market, especially in the software firm. And on a very important benefit is that the use of the data helps companies, many companies, save money and develop better marketing strategies, improve the efficiency in procurement, support the growth of business, and differentiate themselves from the other competitors in the industry. And this is the broad perspective of the data analytics, which we are going to discuss. Now, what is the data analytics? It is the management of all the users, maybe operationally or analytically, and analyze the data in a better way, finally, to gain the insights from the data to drive the business process and improve the business outcomes through more effective decision making and enhance the customer experiences. And as many of the companies are running on the customer's behavior, so it is more required to have the customer experiences enhanced so that the better the decisions can be taken by the industries. Now we come to a basic level to advanced level, how we go ahead with the data analytics. First of all, what is a data? Our data is all about some raw information. It might be in a papers, it might be in a figures, facts, text, characters, symbols, or any kind of things. It is not organized in a proper way, then I can call it as a data. And this data can be of various types. It may be of a qualitative data or a quantitative data. And we have to make or convert this data into a meaningful information. Then out of this meaningful information, we can go for applying our analytics. So meaningful in the information, in the sense, whatever the raw data you have in the data analytics, the raw data will be converted into a meaningful or organized data, maybe in the form of tables and maybe in the form of XML data, because whatever the data you have here, the data can be classified into three categories called structured data, unstructured data, and semi-structured data. You can put this data in any one of the form and make your data as a meaningful data, then it becomes an information. So once you have an information available with you, then we can go for performing the analytics. What is the analytics? So once you go for applying some techniques or methodologies or algorithms over your information, you discover something, you interpret something, and you have a meaningful patterns, or sometimes you can get some aggregate information or summary of the data. So the data analytics is nothing but as a process of examining your data sets in order to draw some valid inferences or conclusions from the information it contains. You can just say that analytics is just not any tool or a technology, rather than how the data analyst expert think and act on the data. You have lots of data available in the market, but how this data will be really fetching to the students and companies also. So we go for examining the data. Once we examining the raw data, then we can go for predicting the data in your Next, we go for analytics. So, generally, all the raw data, from where you are getting all this raw data, either from the discussion boards or from the emails or exam logs, and many of them customers or I can say clients are using the social networks where we can go for getting enormous data from the social networks also. Chat logs in e-learning system which can be used to find fruitful patterns and relationships. So to once the patterns is being evaluated, what is a pattern here? First of all, you have to know pattern is nothing but the sequence of items or the sequence of information that you are having and how it is going to relate one item to the another item where we go for establishing the relationship. So, all these patterns of the relationship can be visualized using exploratory visualization or confirmatory visualization based on what kind of data we are going to use. Because whatever the patterns you are getting from your raw data, you have to visualize. Once we go for visualizing them, we go for capturing the better relationships from the unknown things. As many of the examples in this data analytics, we have a better example that in US market where in every Saturday and Sunday diapers and beers were sold, right? And this diaper and beer has no relationship at all. But how this two items, diapers and beers, are getting sold in the international market. So in that particular scenario, this data analytics is going to capture the relationship between the diaper and beer, because the relationship they found out of this data analytics is that the father has to take care of their kids on every weekends, Saturday and Sunday. So the fathers are enjoying the beer with diapers to their babies. This is the relationship they have been identified in the data analytics. And sometimes we can also go with a confirmatory visualization where we have a theory driven data. So I can go for having the different definitions with the different agencies. What is a data analytics? So as per the Wikipedia, data analytics is a process of inspecting, cleansing, transforming, modeling the data with the goal of discovering useful information. And also from that, we go for getting valid conclusions, valid inferences, as well insights we are going to get which supports the decision making. And according to the Gartner's the statistical analysis, data analytics is nothing but leveraging the data in a particular functional process and application to enable context-specific insight that is actionable. And as per the American Transmission Company, ATC, right, it is using data analytics is nothing but is using our current data set to extract useful information, support decision making. So, out of all these definitions, finally, we are going to visualize the data in the form of dashboards, or you can visualize in the often single pages, or you can use any of the user interfaces, graphical representation of your data in the form of bar graphs, in the form of pie charts, or scatter graphs, or whatever the visualization presentations you have, you can go for adapting. Now, we come to what are the capabilities of this data analytics. So, once we come to the capabilities, we can see on the x axis, as per the Gartner, the difficulty level is on the x axis. As the difficulty level increases, we go for getting the foresights. And we discuss what is hindsight, insight, and foresight. The complexity will be increasing, and the value also increases in the y axis. You can see as the y-axis value is keep on increasing, the value increases from your data, as well as the difficulty of extracting the value also increases. So we get initially the information. So from the information, we have to go for optimizing that information finally to get a valuable data, or I can say a wisdom, whatever you get from your information. So now we come across what is the descriptive analysis, what is diagnostic analytics, what is predictive analytics, what is perspective analytics. So we come up with a descriptive analytics. What happens? Generally, descriptive analytics tells you what happened in the past, and diagnostic analytics helps you understand why something happened in the past, why something happened in the past. Suppose you go to the doctor, you suffered with some disease, they are going to have a diagnostic analytics that something happened day before, and you are consulting the doctor to identify what it is, right? Next we go for a predictive analytics, where the predictive analytics predicts what is most likely to happen in the future. Right, just in statistics, always we go for predicting based on the sample data. The best example you can give for the predictive analytics. And perspective analytics always recommends some actions you can take to affect those outcomes. So, from these three, whatever the actions you take, so that the effect of those outcomes will be increasing and it will be the benefit of the organization. Now we come up with a insight. What is the insight of your data? I can say that insight or a descriptive analytics can only tell you what happened. All right. So it is just a backward looking onto the limits of the quality of the data factual. So hide insight is always a necessary part of analytics where we come across. And what is this insight? Insight is nothing but value obtained through the use of analytics on your information, right? So whatever the information you have, you apply some analytics over that and you get an outcome as a valuable value. I call it as an insight, then I call it as a insights, foresights, or I can call it as a perspective analytics. Always tells you about what to do about it. And there are always many kinds of perspective analytics available where we can go for using the perspective analytics. Now, we come across the basic difference. Everybody know about the statistical analysis. Now, what is the major distinction between the statistical analysis as well as data analytics? Once we go for a data analytics, it always utilizes the data mining techniques. Data mining techniques is nothing but the approaches which you are using to mine your data. And here we go for utilizing the statistical or mathematical models. And in the data analytics, it identifies inexplicable or novel relationship trends, which is unknown. Which is unknown. We are going to derive a new relationship or a trends that exist in your data. Whereas in the statistical analysis, we go for using based on your theoretical foundation. And it always seeks to visualize the data to allow the observation of relationship or trends. Whereas here in the statistical analysis, we seek to identify a significant level to address the hypothesis. So this is the major distinction between your data analytics and the statistical analysis. And these are the various applications where the data analytics are applying in the current world, like a customer insights, because always the customer need some valuable insights in it, smarter healthcare, science and research, right? Performance, business insights, traffic controls, retail solutions, finance, personal insights, sports, performance, homeland security, and number of applications, or you can just have a glance of areas of data applications where we can employ. First, we come with the policy and security. So what is the policing and security? So several states or cities all over the world have been employed predictive analytics in predicting the areas that you would likely to witness a surge in a crime, right? With the use of geographical data and historical data. This shows that this kind of data analytic applications will make us have safer cities without police putting their lives at risk, right? So policing and security is a major area where the data applications can be done. And transportation. A few years back at the London Olympics, once we had, there was a need for handovering 18 million journeys made by the fans in the city of London. Unfortunately, it was sorted out using the analytics to ensure the large number of journeys went very smoothly using the data analytics in the transportation application. And next application is fraud and risk detection. So many organizations nowadays have very bad experiences with the debt and they were fed up because many customers are not going to pay back their debts. So since the data that was collecting during the time of their customers applied for the loans, they applied data science, which eventually rescued them from the losses they have been incurred. And this helps a lot in recovering the loan from the customers. This led the bank learning to divide and conquer the data from the customer's profile, recent expenditure, and other significant information that were available to them using data analytics. And they start making it easy for them to analyze them and infer if there was any probability of the customer defaulting. As well as in companies, many of the organization, they can go for managed risk. These days, analytics software is used for detecting the various forms of fraudulent claims. So, risky claims are always detected by the red flag indicators, which can be examined in the companies. And in the delivery logics from data analytics application, these companies has found the most suitable routes for the shipping, the optimal route, the best delivery time, and most suitable means of transport to select so as to gain the cost, efficiency, any other factors. And what is vision provision? So, vision provision in the web. So, once I go to the web provision, there is this general belief that smart cities always have very fast speed provided by their government or the companies present, therefore declaring them smart. The key component of this is being able to shift the bandwidth to the right location at the right time. Are you getting? So web provision you are giving, and many cities feels that yes, we are having very rich internet with very broadband, but that is not a point. The bandwidth wherever it is not utilized is being diverted and is being used for the really where the need of bandwidth. So here the key component of this is being able to shift the bandwidth at the right time at the right location, and this also can be achieved by using the data only. Proper spending. Suppose you go, many cities have issues in large amount of money spent on a little work. So small changes are the landmark remodeling, which one could dismiss an unnecessary projects consuming. Likewise, you have all these applications like customer interaction, city planning, travel, energy management, internet web search, digital advertisements. All these are the various applications where the data analytics is being used, and it is being really making the valuable insights and drawing the valid conclusion and improving the applications in various applications as listed. And now we come to the big data. Right. So, what is the big data? Why you need to go with the big data? So, always when we talk about the big data, you talk about four V's here. You have variety of data, means that you may have structured data, unstructured data, or a semi-structured data. You have huge volumes of data, you have a much value in the data, and you have a huge velocity of the data. So once we have all these three V's satisfied, then I call the data as a big data, which is handling the various data that is emitting from this various applications. So you can see here location data, GPS, machine data, right, SMSs, point of sale data, clickstream data, social networking, sensor data, ERP data, RFI data, mobile data. Likewise, huge data is being emitting from various devices across the country, and you need to go for performing the analytics on this data. It is not possible with the normal. So we come with the big data. So what is the role of the big data here? So once we come to the big data in the context of machine learning, because our topic of today is machine learning, so we discuss the big data in the context of machine learning. So machine learning always requires that right set of data be applied. So always you require a proper right data that can be applying your machine learning as a learning process. So an organization does not have to have a big data to use machine learning techniques. But however, big data can help to improve the efficiency, accuracy of the machine learning models. We go with the machine learning, but how that machine learning is going to improve your big data in terms of accuracy, it is going to improve. And with the big data, it is also possible to virtualize the data so that it can be stored in the most efficient and cost effective manner in a different platform. In addition, many of the improvements in the network speed, reliability have been removed. Other physical limitations, whichever is associated with managing massive amounts of data at the acceptable speed, has been changed, and almost all the data is now stored in the cloud. So, using the cloud data, you are going to mine a very big data using your machine learning approaches. So, applying machine learning, which leads to the business needs. So, many business organizations, why the industry is picking or grabbing the students only from the analytics is they want the business needs to be satisfied. So, if they want their business needs to be satisfied, they have to apply the machine learning. So, machine learning always offers some potential value to companies. That is why they apply machine learning. So, what is the potential value? Potential value may be in terms of money, or in terms of economy, or in terms of trustee value. It can be any. We cannot always talk about a potential value in terms of economy, in terms of money, but in terms of trustworthiness also we can go for offering the value to the companies by using your machine learning, because many companies are trying to leverage big data and helps them to better understand the changes in the behavior that happens in their organization, preferences of the customers, as well the customer satisfaction, as well the customer behavior. So business leaders, whoever are in the current competitive world, are being to appreciate that many things happening with their organizations and industries which cannot be understood through writing any queries, because before in the traditional system they start writing the queries and getting the information, but nowadays it does not work out for the business readers. That is why we have many hidden patterns and anomalies which is buried in the data that can help or hurt you, right? So that is why we go for the business analytics for the big data using machine learning approaches. So once we come across this distribution of data where 48% of the data comes from the customer analytics, 45% of the data comes from experience analytics. Likewise, the risk analysis, regulatory compliance analysis, fraud analysis, location based targeting, brand sentiment analysis, campaign optimization, threat analysis, product placement, company drug discovery. Likewise, n number of top big data use cases are currently available, where the widespread of use of these personal computers and wireless communication always leads to big data, because every single individual or a person is now holding the mobile, which is holding the cloud, which is holding the entire information about an individual. So we are both the producer and customer consumers of the data. We produce the data as well, we consume the data from your mobile or laptop or any form of resources. So the data is not random, it has sometimes structure like customer behavior. So we need a big theory to extract that. The structure from the data is understanding the process. And once you understand the process of your data, then you can make out the predictions for the future. Now, So this is all a brief, detailed data analytics introduction. Now we come up with the machine learning. So why the machine learning is required for the data analytics? And in machine learning, what are the various learning approaches we come across? We'll have a short learning. So what is a learning? So before going for machine learning, so first we have to discuss what is a learning. So learning is nothing but here we can go with, sorry. So why we need to learn? So learning is nothing but we make the system to learn. So we make the system by using our data, and we make our data to understand by the computer. Then I call it as a machine learning in general. So I can define machine learning is a programming computer to optimize a performance criteria using the data or the past experience. So always there is no need to learn to calculate payroll. Yes, everybody can do that. So learning is always used when human expertise does not exist. Like you have a best example, navigating on maps, you don't have expertise, then I can use the learning mechanism. Humans are unable to explain their expertise, speech recognition, and solutions change in time as and when the dynamic routing will be changing in the computer network. So I should make my system to understand how the routings will be ad hocly changing on the need basis. Solutions need to be adapted on the particular cases based on the user biometric. So learning is always done when you don't require your expertise. A human expertise is not required, and where it is a role of a machine to understand your data and then perform your data and draw the valid conclusion by using the learning. So why we want to talk about and when we want to talk about learning? Learning general models from a data of a particular example, right? So data sometimes may be cheap and abundant. So data is always available in a huge data warehouses and sometimes in the data mods where the knowledge is were always expensive and scarce. So example, if you consider here the customer transaction to customer behavior, so people who bought Blink also will bought outliers, right? So this is the best example. That means whoever, I can give another example, who can buy a computer will definitely buy a software. Yes. So this is how I can go for having the relationship between the customer transaction and the customer behavior or consumer behavior. So built a model that is very good and usefully approximating the data. That means you give the data to the computer or the machine, and the machine starts understanding your data and it starts predicting something out of the data. Then I call a basic data machine learning approach. So the learning has been evolved since 2300 years ago. The Plato, a famous researcher in 427 to 347 BC, the concept of abstract idea are known to us as a prior. What is a prior? Prior is nothing but understanding something before you perform something. Understanding something, whatever the data you have, maybe legacy data or maybe historical data. You understand some concept over your data, then I call it as a prior. Through a mystic connection with the world, you go for deriving some conclusion. So he concluded, the Plato has concluded that ability to think is to find in a prior knowledge of the concept. So how you get the prior knowledge of the concept? Through the mystic connection with the world, then only you can go for connecting. How do you get the mystic connection with the world? With the legacy data. So now we come with a learning system model. So always you have the input data, right? Input samples, and you test that samples with your learning method, and you make your system to understand both the input samples as well as the output which you have got from the learning method. And whatever the system understand your simple, samples, then I call it as a training input samples. Once the system don't understand your samples, then I call it as a testing samples. So the data can be always divided into test data as well as train data. Train data is nothing but once the system understood, I call them as a train data. Once the system, I don't provide the data to the system and directly apply to the learning method, then I call it as a test data, where I go for deriving the valid conclusions here or predictions or whatever the target you want, you can go for achieving. This is the learning system. Any machine learning model which you are applying, this is a common approach for any machine. Here, only the learning method will be changing based on your input sample. And for your understanding, all learning methods will not suit for all the data. So it depends on the data what you are using. The learning methods also will be changing and you have to incorporate the same. So this is how the training and testing. So what I told, training is nothing but already the understood data by the system is called as a training. So it is well trained data. So this is your complete data input sample you have. So you have the machine or the system or the computer has classified the data into two by observing. I call this as a category A data. I call this as a category B data. And the test data, which is unobserved. You don't observe the data, just you put your data on your model. And sometimes the category A comes to category B and category B comes to category A samples, where it is not observed and where we are not classifying directly. Then I call this as a test data. So, training, I can say, is a process of making the system able to learn. And no free lunch rule here. Training set as well as the test set come with the same distribution, and you need to have a same assumption or bias for both, right? So, the data will be coming, and you have to go for understanding the data both for training as well as the test data. Performance. So once we apply the model, you need to go for measuring the performance on several factors like what types of training is being provided for your data, the form and extent of any initial background knowledge, the type of feedback provided, which learning algorithm you have used, and two important factors considering here are the modeling and optimization. Which modeling algorithm you are using and how optimized the insights you are deriving from it. So, origin of machine learning. So, from where? So, just we have a glimpse of learning now. Now, we come to the origin of machine learning, which lies in very early efforts of understanding. So, what is an intelligence? So, before going for machine learning, because we have to extract the intelligence from the information. So, from the information, you can extract intelligence. From the intelligence, you can extract the wisdom, right? So, what is an intelligence? It can be defined an ability to comprehend, to understand, and profit from the experience. And you should have the capability to acquire the knowledge as well as apply the knowledge. Who can acquire the knowledge? Who can apply the knowledge? The analyst who have a knowledge on a particular data, they only can acquire the knowledge. Not a normal person can directly go and acquire and apply the knowledge. It's not at all possible. So whoever the data analyst, they have a better idea on the data, they only can acquire the knowledge as well, apply those knowledge in the company in the form of business rules or in the form of recommendations or in the form of profit loss, right? Whatever the scenario, they can go for applying their knowledge. So, what is a machine learning? So, we can finally say whatever the learning approach, whatever the training approach you have, and you apply your learning models, you automating the automation. Getting the computers to program themselves and writing the software is a bottleneck. So, let's the data to work. So to understand better, we'll look at what is the main difference between your traditional programming and your machine learning. 1 minute. So here we can go. A traditional programming, where generally for any programs which you do in your regular lab, you have a data input values, you write a program in your computer, you give an input and you get an output from the computer. Yes, it may be any kind of program. And coming to the machine learning, you have the data, you know what output it has to be generated because you are the expert. As a data analyst, you understand well what is the data, so you know what output you are getting. And computer will understand both the data as well as output by applying the machine learning, and it will generate a program. This is the main difference. Once you understand this difference between your traditional programming and machine learning, then you can go with the working out with your machine learning, right? So, machine learning, why it is and why, what it is and why it matters. Always we can say the machine learning is a method of data analytics. That is why today our webinar topic, appropriate title is Data Analytics Machine Learning Approaches. So, machine learning itself is a method of data analytics that automates any of your analytical model building. So, machine learning, I can say it is a branch of artificial intelligence based on the idea that systems can learn from the data. System is going to learn by the data, identify the patterns from your data, and it makes the decisions with a minimal human intervention. Somewhere the minimal human intervention is required. So, why is machine learning very important in the current world? So, researching in interest in machine learning is due to some factors. Always, you have data mining, Bayesian analysis, right? More popular that generally you use in your statistics also, Bayes theorem. So, things like growing volumes and varieties of available data, the computational process is becoming cheaper day by day. In the old traditional days, the computational processing is very huge, it is very cost, right? But as all the data is going volumes and varieties of available data, the computational processing also becoming cheaper and more powerful, right? And it is affordable. Data storages is available with the help of the cloud, and all of these things means it's possible to quickly and automatically produce the models. So once I want to go for quickly and automatically producing the models, this data analytics with machine learning, incorporating the cloud technologies. So you have Amazon Web Services, right? So all the Amazon Web Services is providing machine learning as a one of the service to have the better analytics in the tool of AWS. And you have many certifications in the AWS where you go with performing analytics using your machine learning algorithms in the AWS. So the students are grabbing more packages in this particular sector. Once you go with connecting these three things, machine learning, data analytics, and the cloud infrastructure services, whatever you have, once you are familiar with these technologies, a minimum of 15 lakh to 20 lakh package you can gain from the industry, irrespective of your degree. Even the degree students can go for getting 15 lakh of package once you are efficient in doing with the AWS and data analytics and the machine learning. So you can see the machine learning is a part of your artificial intelligence. So once we want to learn about the machine learning, you have to understand what is supervised learning, what is unsupervised learning, and what is reinforcement learning. And this is a deep into the concept, deep learning. We will leave the topic for today. We'll discuss these three in this webinar. So, what is machine learning? A branch of artificial intelligence. Always we go for designing and development of algorithms that makes your computer to evolve the behaviors on your data. So, as the intelligence always requires the knowledge, it is necessary for the computers to acquire the knowledge. Who will provide the source to acquire the knowledge, your machine learning algorithms. So your machine learning algorithms is necessary for the computers to acquire the knowledge from your empirical data. Without machine learning algorithms, how can you extract the knowledge? You, in the sense, the computers, cannot go for extracting the knowledge from the data. So we require some machine learning algorithms. So we can look at machine learning algorithms like this. We sow the seeds, so you are just like a gardener. Who? The seeds are nothing but the machine learning algorithms, right? And nutrients is nothing but the data which you are using on your algorithms. And the gardener, you, where you fetch your data and you apply the algorithm on the data. Then the plants will be grown automatically, in the sense the programs will be generated. Right, as we have told here, the programs will be generated. Once you have a data, once you have a machine learning algorithm applied on your data through computer, the algorithms, you get the program. So machine learning, in a nutshell, we can say that tens of thousands of machine learning algorithms, huge number of machine learning algorithms are available, and you have to go for using this machine learning algorithms in a three-component manner. And based on your data, you can choose a right machine learning algorithm. Once you have a knowledge, once you are a data expert, once you are a data analyst, you can go for choosing a right machine learning algorithm that have three components. One is representation, evaluation, optimization. So for representation, we can go for using. So here we are going to have a three components for every machine learning algorithm, whatever you use to perform analytics. Representation. So we can use decision trees, we can use logic programs, instances, Bayes theorem, neural networks, support vector machines, model ensembles. This is a glimpse of representation algorithms which you have in the market where I can go for using. And coming to the evaluation, always we should have some basic metrics to evaluate that whatever the analytics you have performed is evaluated right as per the accuracy, precision, recall, any error rate, likelihood, posterior probability, cost, utility, margin, entropy, KL divers, etc. So these are all the various metrics I go for applying on our machine learning algorithm output. Thereby, I can measure the things whether my mining algorithm or a machine learning algorithm is working properly on my data. If my machine learning algorithm works properly on the data, I get accuracy 100%. I get my precision, more precision. I get my recall, more recall. Squared error, less. Likelihood, more. Posterior probability is nothing but the prediction Posterior is nothing but in future. What is going to happen? Estimating with the probability. I can predict something. Then you can go for evaluating the cost, utility, margin, entropy, how best you can go for using your attributes of your machine learning. All this evaluation will be done. And representation, as you know that we have variety of representation tools available, like Tableau is one of the tool, or you can use your Excel itself where you can generate a lot of bar graphs, charts, dashboards, smart boards, whatever you have. You can go for using all these for your representations. And what required to create a good machine learning system? So I want to create a better and good machine learning system. This is my machine learning system. So what all I require to make my machine learning system good? A data preparation capabilities. You have to prepare the data so that your machine can understand, can process your data using your algorithms. The algorithms may be the basic algorithms or the advanced algorithms. And once you apply the algorithms, you go for automation and iterative process of applying the algorithms on your huge amounts of data. And you also check the scalability. that how much size the data can be keep on increasing. As the data keep on increasing, sometimes your machine learning algorithm is not able to predict something out of your data. So you have to check the scalability issues also. And finally, you have to ensemble modeling. So, algorithms. Coming to the machine learning algorithms, always depends. So once you have a success in your automation of your machine learning systems, I can say my algorithms is working well. My algorithms control the search and it is going to build the knowledge structures. Learning algorithms should extract useful information from the training sets. And algorithms are likewise classified. You have vast number of algorithms, but I have listed here only the few algorithms under the supervised learning and unsupervised learning, as well as semi-supervised learning. So once I go for categories of algorithms, you have support vector machines, linear regression, logistic regression, Navy Bayes, linear discriminant analysis. Likewise, you have a number of algorithms which will be coming across in your academics. As well, the unsupervised learning, you have K-means, KNN, hierarchical anomaly detection, neural networks, PCA, principal component analysis. These are all the unsupervised algorithms. What is the main difference between supervised, unsupervised, and semi-supervised learning, and how the scenario goes? We will see with a broad glimpse. So, coming to the supervised learning, we already know the output that this students belongs to excellent band, this students belongs to good band, and this students belongs to a satisfactory band. Right, here you have a clear patterns which is distincted from one group to the another group. It's called as a supervised learning because you know the label. This label is excellent label, this label is good label, and this is a satisfactory label related to student grades. But once you come to see your unsupervised learning, you don't have the distinction between the three parts here, right? All looks similar data points. All looks the similar students. You don't find any characteristics here. Then I call it as I don't have any labels like here, excellent, good, and satisfactory. I don't have any class labels here to identify what this object is, what this data object is, what this data object in the sense student. All these are the real-time entities. I don't know the characteristics of the real time. Then I call them as a unsupervised learning. And semi-supervised learning, having a mix-up of all both supervised as well as unsupervised put together, I call it as a semi-supervised learning. So, machine learning in today's world, by using all these algorithms, we build the models. Once we build the models, we go for uncovering the connections. Organization can make better decisions without human intervention. Learn more about technologies that are shaping that world we are living. That is the main purpose of your machine learning in today's world. So you always discover, uncover connections. Organizations take better decisions without human intervention. Now we come in detail of your learning techniques under machine learning. So as we discussed, we are classifying the learning techniques into three: supervised, unsupervised, and semi-supervised. So in semi-supervised learning, always the input data is pre-classified with the unique concept labels just now I have specified. In unsupervised learning, your input data is not at all classified. It contains only the input data and you don't have any labels here. Then I call them as a unsupervised learning. In semi-supervised learning, which is the combination of small amount of labeled data and large amount of unlabeled data, then I call it as a semi-supervised learning. Now we go in detail. What is supervised learning? So supervised learning is a process of providing the data as well as correct output data to the machine learning model. The aim of the supervised learning algorithm is to find a mapping function to map the input variable and the output variable. So under the supervised learning, we have various methods or supervised learning algorithms like linear classifier, parametrics, non-parametric, non-metrics, aggregation. So these are all the various methodologies we can apply under supervised learning. Next, we go with the architecture, how the supervised learning architecture resembles. So here we have your inputted data, and you have the class labels in the sense categorization of the data. From this input data, I go for extracting the features in the sense, suppose if I consider the student, I go for extracting the marks of the students, and the labels I have as a good, excellent, and satisfactory. I am providing both these features as well as labels to the machine learning algorithm. So machine learning algorithm is going to have the prediction model to be applied. And this is the training data set and this is the test data set. So where you have a new text which is not a trained, here you have training your machine, your system. But here the new text which is not a trained will extract the feature and it apply on the predictive models. That means 80% of the data you can take from the trained data set and 20% of the data you can go for with your test data and you apply your prediction model. Then you get your expected label. The expected labels are already here, but you don't have for your training data set. So by using your prediction model, I go for deriving the labels for my test data also. Clear? And coming to the unsupervised learning, where no labels are given here, right, for the learning, and you leave it on your own structure of your data. So unsupervised data can be a goal in itself or a means towards an end feature. It has to find its own features itself. So for this unsupervised learning, we have parametric, unsupervised learning, non-parametric, and you have these methods to implement your unsupervised learning in the machine learning, right? So we go for Gaussian mixture models. You go for using expectation maximization algorithms, non-parametric, unsupervised learning. We have the clustering algorithms. Coming to the architecture of the unsupervised learning. So here you don't find any class labels as we have seen previously in the supervised learning. You have the labels here. But coming to the unsupervised learning, you don't find any class labels here. You just extract the features. You apply your machine learning algorithm. Similarly, for your new data set, test data set, you go for extracting the feature and you apply your prediction model where the outcome is here, not the class labels. Here the outcome is generally in the supervised learning, we are going to have the class labels, but here we have the likelihood or the cluster ID or better representation of your data as an outcome. And coming to the semi-supervised learning, where I said that less number of label data and more number of trained data, right? Then we use unlabeled training data sets to predict the output, which are pseudo labels, since they are not to be quite accurate, because whatever the labels you are extracting, it may be correct or it may not be correct. So you link the labels from the labeled trainings because you have a small amount of labeled training data. So you link your predicted labels with your labeled training data with the pseudo labels created. So once the link the input data in the label training data set with the inputs in the unlabeled data. So then train the model the same way as you did with the label set in the beginning in order to decrease the error and improve the accuracy. Only the thing is final motto is you have to decrease the error and improve the model accuracy. Coming to the machine learning structure of semi-supervised. So here you can see this is the learning algorithm. This is the unlabeled data. This is the raw data. From raw data, you have unlabeled data as well as you have learned data. Here you can see these two are the learned data. This is face, this is not a face. That means you are classifying into two labels. One is face label and another one is not face label. Whereas here, you are not classifying anything here, right? And you are just giving directly the input to your learning algorithms. And learning algorithms is going to classify by using any of your machine learning algorithms. So, coming to the supervised learning, you have an offline batch versus online incremental learning under your supervised as well as unsupervised learning. What is this offline learning and what is this online learning? So, offline learning always refers to the situation when the system is not operating in your real time environment. It only handles some static data, cooked data. Then I go for completing in the form of batch, like batch processing. And coming to the online learning, where I take the data from the real time in an incremental fashion. Just example, I can take the streaming data. So whatever the streaming data, now we are streaming. So the streaming YouTube data is having both audio as well as video. In an incremental fashion, we are going to provide an input for your machine learning. And input data items are incrementally, gradually, and continuously used to inductively extend the existing model. Right. Now, what is the concept learning? So, this is a new point of concept learning where you are going to acquire the things by framing the hypothesis from the given data and getting the best solution out of it. So, what is this concept learning? So the problem of inducing general function from the specific training examples is central to learning here. What is that inducing means? You can say that a concept learning can be formulated as a problem of searching. That means you define your hypothesis. What is an hypothesis generally? You have a problem, you assume some solution, right? So whatever the solution you are assuming is nothing but the hypothesis for a problem. So once the hypothesis fits into your training examples, then your problem is solved. Yes. So the concept learning is much or more same like that, fitting your solution into the problem for a given data set. For a given data set is called as a concept learning. So we take an example to better understand what is the concept learning. So to better understand the concept learning, so we have an example here where you have an attribute, a labeled attribute, enjoy sport. As a student, here you can take whether Shri is a person wants to enjoy her favorite water sports on this day. That means enjoy sport is a label. Yes or no. You have to give yes or no. Shri is going to enjoy or not. That you are going to have as a concept learning here. Right. So we take an example here. So the objective is the problem is to learn enjoy sport. You have n number of records. So we are going to enjoy the sports in a particular environmental conditions or not. So if Shri wants to play, whether she will play, she will enjoy the sport or she will not enjoy the sport in different climatic conditions here. So all the climatic conditions, the six features I can say here: sky, air temperature, humidity, wind, water, forecast are the six features. Based on these features, we can predict that Shri is going to enjoy the sport or not. So, Tom enjoys his sports, favorite water sports. How? When the sky is sunny, air temperature is warm, humidity is normal, and wind is strong, water is warm, forecast is same. Then he will enjoy the sports. So that means based on the values of these features, the Tom or Shri can enjoy the sports, labeling as yes, or will not enjoy, labeling as no. So enjoy sport is a labels where we are going to have yes, no, labels. So if it is rainy and if it is cold, if it is high humidity and strong wind, water is warm, and forecast periodically changes, then he will enjoy the sport? No, obviously, no. So likewise, we can go for having the concept learning. So all these are called as input variables. The objective or the problem here is to learn, enjoy sport. Yes or no for all the students. So input variables I am considering to assess the output as enjoy sport. Yes or no. I take the input variables as sky, air temperature, humidity, wind, water forecast, which is going to predict the enjoy sport. Yes or no. Enjoy sport as yes or no for a particular environmental variable. So we can take a general concept learning task notation as all 6 variables or features can be represented as x1 to x6, and your output variable can be represented as y, which will be predicting based on the values of these 6 input variables. So I can call all these as an instances, and finally what I will get, I call it as a target concept, and all the data values here we have, which is highlighted in yellow color, or called as a training examples, the data, right? So this is about your characterization of learning. Now we go for how this learning problem scenarios for the concept learning. So now everybody know concept learning. So how we can go for characterization of learning problem scenarios for the concepts. So first we'll take a scenario where all the you have only one label for all the data, right? So I have all the data points here. For all the data points, they belong to extraordinary. Suppose if I take a student, all students in this group are extraordinary students. That means I have only label 1. Then it is called as a scenario. Learning a single concept. The concept is only one because all students are very good. I cannot distinguish very good students from very good students who is extraordinary offline from the pre-classified positive example. So first concept is being derived. Scenario 2, learning a single concept offline from the pre-classified examples. So noise here. So within this, whatever the data I have, I called it as a regular data. Out of this circle, whatever the data I have, I call it as a noise. I call it as an outlier. So noise is a fundamental outlying phenomena here that is represent in all the data sets. Generally, you have a noise. I can define the noise as a distortion in data that is unwanted by the perceiver. So whatever the data you have here, that is not required for your company. So noise is anything that is spurious, extraneous to the true data, and typically due to the faulty capturing process, you will have this noisy data. And this noise can occur in all subsequent scenarios as well as in the first simple one also. We have to go for identifying the noise. Once you identify the noise, then you have to call them as an outlier, right? I remove an outlier which is distinct, which is far away. In the previous point, you can see it is out a little far from your classified data, right? But once we come to here, I have a very large distance from your observed data to the these points. Then I call it as outlier, which does not match with your regular data points or data items. So an outlier can be defined as a data item that is distinct from the other observations. So an outlier may be due to natural but extreme variation. You have an extreme variation. It may indicate an experimental error or any other noise. Negative examples. So once I go for negative examples, for many situations, many machine learning algorithms, fast convergence towards the concept definition can be achieved by using a mix of both negative and positive values. So negative Values or examples can be made available in variety of ways so that I can identify the positive values. You should always have the negative values. Is another scenario where you go for learning a single concept offline from the pre-classified. Near misses, it is almost inside your category, but slightly it is missing from your data, right? From your existing data points. So in this data set, all your negative examples are used. It is not obvious what type of objects we should use as a negative example, right? Arbitrary some negative examples will differ considerably from the positive example based on the characteristics. Based on the characteristics. So whatever the characteristics here you are going to classify all these data objects belongs to a similar characteristics. But whatever you have outside of this boundary, a classification point, I have a characteristic from this point to this point is varying a little bit. All right. So near misses or negative examples that differ from the learned concept is only a small number of significant points. Scenario 6, we go for learning the concept by the internal structure. Now we start identifying the internal structure and topology of your data of one particular concept. Here we are talking about only one concept, not multiple concepts. You are talking about only one label. But generally in data, you have n labels. But to better understand, we go with one label and one concept. So this scenario, internal structure and topology of the data, introduces the concept of how the objects and similarity metrics are there within the data set. So if the points are near to each other, then they can say more similar. If the points are far, suppose you have one point here and one point here, the distance between one point to another point is far, then I can say that characteristics is as variation. You have a variation in the characteristics. Instance based learning. So what are the instances? So instance based learning, or I can call it as a machine based learning, we mean the learning algorithms. Instead of creating an explicit generalization, we compare a new problem instances with the instances that you have already been stored in the memory. So one advantage of this instance-based learning is over other methods of mission is availability, that you can easily adapt its model to the previously unseen data because you have already in the memory. And once you have in the memory, once I give a new data, it matches with the memory data, and you don't require that much time to have a mapping between the internal and external data, and which makes us store a new instances or may also throw old instances away from it. Online learning. Online learning is a many of the machine learning is going to implement online learning concept, where online learning is a learning scenario where the data is always processed in the real time, clickstream data, streaming data, byte stream data in an incremental fashion. The data will be keep on giving. So input data items are incrementally, gradually, and continuously used to inductively extend the existing model. Finally, the outcome will be results of the earlier learning are typically maintained. So, as we take an example that many of our social B2B business, we have Amazon, right? Every hour they start analyzing the customer behavior. How they can start having the analysis of customer behavior by having the online learning. Every time, whatever the customer click and browse, each and every product of the Amazon is being captured and is being learned and is being understood, and the recommendations will be given for the customer in turn. Right? This is what happens in your online learning. Throw away the data items that is being irrelevant. So generally we remove the irrelevant learning. In online learning also, all the data items that has been encountered and will be resulting in monotonically growing effort data. So in spite of that, we can go for removing the older data items here. I can say this is the old data items which may not be relevant to analyze the current situation. I don't require yesterday data for today's analysis. Right. I don't want the previous week data for today's analysis. So I can go for removing the older data items, which may become irrelevant for today's perception. So this means that the concept definitions may have to be revised due to the retractions. Right. Machine learning algorithms can handle your online cases and also handle the kind of situation. And this is the situation where we have learning multiple concepts, both offline from the pre-classified classifiers. Up to now, we have been discussing about the one label. Now we can go with the multiple labels and multiple concepts can be defined. As at the beginning, we have only one concept, enjoying playing, right? Now we have a different concepts, right? And different labels are being allocated. Unsupervised learning, right? Unsupervised learning, you don't have the all aspects from 1 to 10 scenarios what we have discussed here is relevant to consider, but input data, once it is not classified, right, this data is not classified as before scenarios, only the input data observables and lack output data observables. So unsupervised algorithms are available. So we apply all the unsupervised, whichever is relevant for the data, to identify the commonalities and to identify the structure in this particular data set. Finally, using that unsupervised algorithm, I can group certain data items which belongs to one concept, certain data items which belongs to concept 2, certain data items which belongs to concept 3. So the main categories of techniques that tackle the unsupervised case is called as a cluster analysis. So this is a final slide where we go for end-to-end process of the process learning, concept learning. So in the typical concept learning task, the following steps need to be considered. Data harvesting should be done from potential heterogeneous sources, because always the data will be coming from different sources, maybe from mobile, computer, desktop, or gadgets, or any kind of data tabs. You will be getting data from various heterogeneous sources, and we need to pre-process them, establish a model for support and theory. Then we go for extracting the features from it by applying your algorithm by feature engineering, select your best machine learning algorithm, tailoring conditions apply for your algorithm, and finally extract the insights from your algorithm. And still we have some examples. No need to go with that examples. We have generally, once you start, you want to start with ML practice, you have to understand. The very first step is you need to understand the domain, prior knowledge, goals, and what is the data integration, selection, how to select the data, how to clean the data, how to pre-process the data. It's nothing but readying your data for applying your models and how the learning models can be applied. And once you get the result, right, you can interpret the results, consolidating, deploying, and finally discover the knowledge and repeat the process. Repeat the process. This is what generally the machine learning in practice we are going to do. Right. So major distinction regarding the role of machine learning, data analysis, adaptive system. So the distinction is very relevant for sorting out and understanding various approaches of machine learning. A small borderline will be there between two genres tend to become increasingly burdened. So what are they? We come across reinforcement learning. A reinforcement learning is first we have talked about reinforcement learning, right? Supervised learning, unsupervised learning, reinforcement learning. This is concerned with how the agents take action in an environment as the changing states so as to maximize some notation of cumulative reward. So this is a broad definition of your reinforcement learning. It is assumed that agents can consciously manage the handling of the reward so that the components of the agent can be modified finally to derive or produce a new state. Reinforcement learning. Always it is assumed that agent, always you have an agent which consciously managing the handling of reward so that the component of an agent can modify to produce the new state. So it is further assumed that a typical scenario of reinforcement learning is a strong theory based hardware and software system. And adoption also happens on the margin of system behavior. A typical way of understanding the modeling of environment is you have various methods like Markova decision process, which in turn you can apply for your dynamic program. Right. So with this, I end up the session by having the data analysis where we go with end-to-end process for the real-world problems. So in the typical machine learning application, anything, the practitioners, we must always apply the appropriate data harvesting, pre-processing of data, model, feature engineering, algorithm selection, tailoring conditions for the algorithm, core analysis phase, post-processing of knowledge acquired, what you have to do with that knowledge, and finally, visualization and preparation for the companies to take decisions. With this, I end up the session. Thank you.
Thank you, ma'am. This session was very informative and we have gained knowledge about machine learning approaches. Now may I request Dr. G. Sri Lakshmi ma'am, Assistant Professor, Department of Computer Science to deliver the vote of thanks. Please, ma'am.
I deem it a privilege to propose vote of thanks for the day. First and foremost, I thank the Lord Almighty for His blessings and making the session a successful one. On behalf of entire fraternity for college, I express my heartfelt thanks to our guest speaker, Dr. M. Lavanya, who spared her time amidst her busy schedule. I extend my sincere thanks to our Honorable Secretary, Dr. P. Gautam Vaid, for being the backbone of the event. I would like to express my heartfelt gratitude to our beloved principal, Madam Dr. M.K. Malati, for meticulous guidance and encouragement. I also extend my thanks to our professors of the support. My special thanks to all the students participated and rendering a patient cooperation. Once again, I thank you all for your cordial cooperation. Thank you.
Kindly raised for the national anthem.
पंजाब सिंध गुजरात मराठा द्राविड उत्कल गंगा विंध्य हिमाचल यमुना गंगा उज्जल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जय जय मंगल दायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे